Welcome to solverfy.
Okay, this question wants us to show that this function satisfies the wave equation. So the wave equation relates the second time partial with the second space partial. So let's just take some derivatives and see if it follows our formula. So let's start with 1x partial. And if we do that, we get a cosine of n pi x, then a cosine of cn pi t, times our chain rule factor of n pi. And then taking another partial, we'd get another chain rule factor and then a negative cosine. So simplifying this, we get negative n squared pi squared times sine of n pi x times cosine of cn pi t. And if you observe here, the sine and cosine term is exactly what we started with. So this is equal to negative n squared pi squared times f. So now we'll do the same thing, but for the time equation. So the first time partial is negative sine of n pi x sine of cn pi t times cn pi. And then you can see where this is going because we just pick up another chain rule factor and the sine turns into a cosine. So we get a negative c squared n squared pi squared times sine of n pi t, or n pi x rather, then a cosine of cn pi t. And now we're back with our original function, just with some extra stuff attached out front. So this is just negative c squared n squared pi squared times f of xt. And now we can compare that with the space answer. So we said that the second space partial was just n squared, or negative n squared pi squared times f, and then the second time partial was negative c squared times n squared pi squared times f of xt. And now we can simplify this even more because we see that our second time partial is equal to c squared times negative n squared pi squared times f of xt. And based on the stuff above, we said that this thing was our second x partial. So we're finally left with the fact that the second time partial is equal to c squared times the second x partial. And that is the wave equation.